Okay, chemists, today's lecture is about molecular attractions, or what we're also going to call intermolecular forces. Or just IM forces. Okay, so what we saw in class is that the charged wand experiment showed that some molecules are attracted to a charge. So what this must mean is that if we have a water molecule, well, then this end is negative and this end is positive. Now, some students say that, well, why doesn't it push away? Well, all the water molecules line up in a direction that is attractive to the wand, and the side that repels it gets pushed to the other side, so it will always be attractive. Now, we could classify things in the substances we tested today, in two different ways. We have polar molecules, and those are those that are attracted to the wand, so they have partial charges on them. And nonpolar molecules, they don't have a charge. So we can separate our molecules between polar and nonpolar. So the key idea here is that one end of a polar molecule has a partial negative charge and the other has a partial positive charge. And these are permanent. So in a water molecule, this is the oxygen and these are the hydrogens. This oxygen atom is always going to have this partially negative charge. And so this little thing that looks like a music note, I've never really understood how to describe it best. This is a lower case delta. You might be more familiar with the delta, the triangle, which is something you probably saw in physics. But the lowercase d, I draw it just like that, like a little music note. And that means it has a partial charge. Now, a partial charge is much, much, much weaker than a full charge. So a water molecule doesn't have positives and negatives, full charges like in an ionic compound, like you would imagine in Na and Cl, right? Where they have full charges that are attractive. But they do have partially positive and partially negative areas that can be used for attraction. So the individual molecules in polar liquids will respond when another charged substance comes near. So if I draw the wand, let's say positive, 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 because we've removed the electrons with the cloth. Well, when a water molecule comes, if I have this water molecule over here, as it moves close, the O in the water with its partial negative charge is going to be attracted to the positively charged wand, and the H's are going to be repelled, so the water ends up becoming attracted to the wand. And that would be true of any polar substance. So this is actually what causes polar molecules to be attracted to one another. Water is a liquid at room temperature. That means it sticks together. And the reason water sticks together is because of these partial charges. So water here, you can see all of the pluses and minuses are arranged such that they're attracted to one another. And that's why water stays as a liquid at room temperature, becomes a solid when it's cold. It's because those molecules are attractive. So we call this is called an intermolecular force or attraction. So we know inter from our vocabulary skills. Inter means between. So it happens between two different molecules. It doesn't happen in one molecule. A covalent bond is not an intermolecular attraction or an intermolecular force, because that's within one molecule. That would be an intramolecular force. Intermolecular force takes place between molecules. So what we're going to study over the next couple of days are these intermolecular forces. And these are the forces of attraction that occur between molecules. What we're going to find is that all molecules, polar and nonpolar, do interact with each other, but the attractions between the polar ones tend to be stronger than the nonpolar ones, and we'll get into this over the next couple days. So, the question that we studied today: why do some molecules smell while others do not? This is not what we were studying today. I apologize. So I'm going to rewrite this. This is an older PowerPoint that I didn't get a chance to change. Why do molecules stick together? We're probably going to use this question again. So polar molecules have partial charges on parts of the molecule. They're attracted to a charge, and they're attracted to each other because of the opposite charges within the molecule. So different multiple molecules will stick together, and that will give the properties of that substance.